Instead of giving the formula for the n terms of a sequence can also be defined using recurrent equations. So here you have an equation relating fn plus 2 with fn and fn plus 1. So basically it tells you add two terms of a sequence to get the next term. This is a famous sequence, Fibonacci sequence. The first term is 1. The first term is 1. The second term is also 1. So you start with 1, 1. And then you add 1 plus 1. You take 1 plus 1. So add the first two terms, you get the number 2, which is the third term. So that's why third term f3 is f2 plus f1. Then after getting the third term, to find the fourth term, you take the third term plus the second term. So it will be 1 plus 2, right? So 1 plus 2 gives you 3. So continuing this pattern, you know that to get the next term, 2 plus 3 gives you 5. So to get the next one, 3 plus 5, so it should be 8. So it should be 1, 1, 2, 3, 5. The next one is 8 because it's 3 plus 5. 3 plus 5. So the next one will be 5 plus 8, 13, and so on. So a sequence can be defined using equation. And it turns out that we have methods to solve this type of equations. And this is the answer. This is the general formula for Fn in terms of n. For this course, we will not be looking at how to solve this type of equation. But if you do a higher level maths course, MA 2214, you'll learn how to solve this type of equation. By the way, this number 1 plus square root 5 over 2 is known as golden ratio, and it tells you how to take a photo, a nice photo. You can Google this and find out the answer. Let's look at an example. In this example, x1 is given to be 1. Then you have an equation connecting xn plus 1 and xn. So we are given xn plus 1 is n plus 1 xn. And you're supposed to find x2, x3, x4. And also find a formula for xn in terms of n. So you also need to find xn equal to in terms of n. Okay, let's look at how to solve it. So you are given x1 is 1. Then xn plus 1 is n plus 1 xn. So we try to put n as 1. Then you will find that it's 1 plus 1 equal to 1 plus 1 x1. We are putting n as 1. So here n, this is n, this is n, this is n. So you're supposed to sub n as 1, n as 1, n as 1 into the given equation. So this will tell you x2 is 2 of x1. And now you see why you are given x1 is 1. Since you are given x1 is 1, you know that this should be 2 bracket 1. So the answer is 2. And let's put n as 2. If we put n as 2, then it should be x2 plus 1 equal to 2 plus 1 x2. So this is n, this is n, this is n in the formula. In the formula here. So with this, you see that to find x3 is just 3 times x2. So it will be 3 bracket, x2 is 2, 2. So it gives you 6. You put n as 3. Then you'll be x3 plus 1 equal to 3 plus 1 x3. So x4 is 4x3. So it's actually 4 times 6, 24. So we have answer to x2, x3 and x4. So the answer is 2. The answer is 6 and then 24. And remember, you're supposed to find xn in terms of n. So we need a formula. So we just found that the question gives you x1 is 1. Then you found that x2 is 2. x3 is 6. x4 is 24. So can you see what is xn in terms of n? 1, 2, 6, 24. Remember just now, this 6 came from 3 times 2. Remember just now you have this, the number 6 actually came from 3 times 2 because x2 is 2. And the number x4 is 4 times x3, 4 times 6. And you'll find that sometimes it will be good you keep the original form. 6 is 3 times 2. So which means 24 is actually 4 times 6. 4 times 6. So it's actually 4 times 3 times 2 times 1. So it's actually 4 factorial. So this one is actually 3 factorial. This one is actually 2 factorial. This one is actually 1 factorial. So which means xn, the formula is actually n factorial. We can refer back to our previous example. So we have n factorial. The last one here, we have n factorial. If you remember this, you also know that the answer is n factorial. So you have 1, 2, 6, 24.